right, good morning, ladies and gentlemen. You can see the bell work right here. Please complete the bell work question on your blue bell work paper. Pause the video for 2 minutes and then resume. All right, you should have checked with your neighbor, but if you didn't, what did you get for the slope of number 1? -2, very good. And number 2, what did you get for the slope? 0. Yes, very good. Okay, today we are doing section 3.5, day 3, writing equations of lines. And everything we're doing today comes from our slope formula. So you just reviewed your slope formula, which was y2 minus y1 over x2 minus x1. And should you be writing this down? Yes, you should, because I'm writing it down. In addition to your title, you should absolutely write this down. So today we're going to use the slope formula to help us write equations of lines. And we're going to do that given a point and a slope, or sometimes 2 points. That's where this formula becomes super helpful. Last week, we learned how to solve proportions. And essentially today, we're going to do the same thing, except we're going to take this denominator, we're going to multiply it to the m on the other side, and we're going to take our denominator here and multiply it to our numerator. I'm going to start there. 1 times my numerator, y2 minus y1, is going to equal my denominator times m, or m times x sub 2 minus x sub 1. All I did was sort of rearrange this equation, this formula. Now, I don't really need to multiply by 1, so it's really just y sub 2 minus y sub 1 equals m times my quantity, x sub 2 minus x sub 1. Ladies and gentlemen, this is point slope form. This is the form that we're going to be using today to help us write equations of lines. It is the easiest and simplest form to do everything in, and the only difference is we don't need the second point here. So we're just going to get rid of that. Y minus y1 equals m times the quantity x minus x1. But it's nice to know where it comes from. This is point slope form, and we're going to use this over and over and over until you have it memorized, and you'll get to use it anytime you want to write the equation of a line. If you're given a point and a slope, you're good to go, or 2 points, which is what we're doing today. So here we go. We are taking notes. You are taking notes, writing everything down. Here we go. Example 1, please write example 1. Use point slope form to write the equation of the line. Use point slope form to write the equation of the line. All right, for letter A here, we have the point 4, -8, and we have a slope of -3/4. And you'll notice we're given a point and a slope, and it's perfect to use point slope form. That's why it was given that name. So right off the bat, I'm going to write down my formula. Y minus y1 equals m times the quantity x minus x1. Ladies and gentlemen, you need to write this down for every single problem until you have it memorized. And when I get back and you tell me the formula out loud, then I will now allow you not to write it down because you'll have proven that you have it memorized. So write it down until you have it memorized. All right, it's very easy here. All we have to do is we're going to plug in our ordered pair in place of x1 and y1, and our slope in place of the m, which is slope. So you have y minus, our y value is -8, so minus the -8 equals our slope in place of the m, -3/4, times x minus, and in this case, 4. All right, we're going to do a little bit of cleanup. Minus the negative, we know we're getting very good at, is +8. And I'm going to go ahead and distribute my -3/4. So I have -3/4 times x is -3/4 x. And then here, we're going to be multiplying some fractions. Billy, stop it. Get away. Okay, sorry about that. -3/4 times -4/1. You'll notice I went ahead and changed my 4 into a fraction. Multiplying fractions is super easy. It's just top to top. So we have -3 to -4. Well, that's going to be positive 12. And then we have 4 times 1 is just 4. And that's it. Numerator, denominator. And now we're going to clean it up a little bit. So we have -3/4 times x, and 12 over 4 is just 3. If you need to use a calculator, you can. I really don't care, but learning to multiply fractions is going to be much faster in the end. One more thing, we're going to go ahead and subtract the 8 from both sides just to get y by itself, because Delta Math wants the y by itself. So we have -3/4 x, positive 3, and -8. It's going to give us a -5. And here is our equation. You should know that it is the equation of a line, and an equation has to have a left side and a right side, but most importantly, it has to have an equal sign. So to have an equation, you have to type in everything. Y equals -3/4 x minus 5. They want the equation of a line. It must have a left and a right side and an equal sign, okay? Keep that in mind. Let's try letter B. We have the point -6, -3, and we have a slope of -1 over 6. So once again, I have a point and a slope. What form should I use? Point slope form. Easy. Y minus y1 equals m times the quantity x minus x1. And we're going to plug in the goodies here. Y minus, in place of y1, what are we going to plug in? -3. Very good. And in place of m, what are we going to plug in? -1 over 6. Very good. And then we have x minus, and in place of the x sub 1, -6. Perfect. I hope you're answering. It's really quite funny when everybody decides they're going to answer along. Clean it up a little bit. We have minus a negative is really a positive. And we're going to go ahead and distribute. And you know what? I am going to clean it up ahead of time because you should never do anything with so many signs. So minus a negative turns to a giant positive. And again, you can do that in your head if you want. From this point forward, we will be doing that as well. -1/6 times x is -1 over 6x. And then here again, I'm going to turn that 6 into a fraction, and I can just multiply numerator to numerator. -1 times 6 is a -6, and 6 times 1 is 6. And a little bit of cleanup. -1 over 6x minus 6 over 6 is just 1. Very last step, we're going to go ahead and isolate y. So we're going to subtract 3 to its friend over there on the right-hand side. We get y equals -1 over 6x. -1 and a -3, that's 4 whole negatives. And again, this is an equation. It must have an equal sign, but more importantly, it has to have a left and a right as well. Okay. C and D are special cases. So we have the point 3, -4, and we want the equation of a line with an undefined slope. Well, what's an undefined slope? That's right. It's a vertical line. And so we want the equation of a vertical line here. Well, let's just think about this just a little bit. I'm going to draw a little picture. My point here, 3, 1, 2, 3, -4. So here's the point 3, -4. Now I need an equation that is vertical that passes through that point. So there we go. I drew it. There it is right there. And now, I want to go ahead, and I'm glad I remembered to look up, because there we go. That's a little better. Sorry about that. When you think about other points that fall on this line, like this one right here, that point is 3, -3. And right there, well, 3, -2. And right here, 3, -1. And right there, oh, 3, 0. Okay, well, you get the hint here. What does every point have in common? The x is always 3. We don't care about the y value. It can be anything we want. It does not matter, but the x is 3. And that's why this equation makes perfect sense. The x is always 3. And that's going to be for any undefined slope, just whatever the x coordinate happens to be. Over here we have a point 2, 5 and a slope of 0. Well, what does a slope of 0 look like? That's right, a slope of 0 is a horizontal line. And again, if we think about it and take a second just to really understand what's going on here, here I have the point 2, 5. And we want a horizontal line through that point. And again, using the same logic as previously, any point on this line, here's the point right there. That's the point 3, 5. And right next door is the point 4, 5. And next door again is the point 5, 5. Over here is the point 0, 5. And what do all of these ordered pairs have in common? That's right, the y value is always 5. And so any horizontal line is going to have the equation y equals whatever the y value happens to be. Excuse me. All right, so again, this is really essential understanding. When in doubt, draw a picture. It really can help clarify a lot of things. All right, let's try one more type here. Example 2. Example 2. Write the equation of the line passing through the 2 points. Write the equation of the line passing through 2 points. So once again, we need an equation of a line. And again, an equation must have an equal sign, but more importantly, it has to have a left and a right side in order to be able to balance. So make sure when you're typing in these equations that they are in fact equations. Well, we have 2 ordered pairs. To write the equation of the line, we need a point and a slope. So what's missing here? That's right, we're missing slope. But if we have 2 points, we can calculate the slope, and that's what we're going to do first. So just like in the bell work, we need to calculate the slope between 6, 0 and 3, 4. So we're going to do y2 minus y1, which is going to be 4 minus 0, over x2 minus x1, 3 minus 6. 4 minus 0 is 4, and 3 minus 6 is negative 3. So now we have a lovely little slope here, negative 4/3, that we're going to use. So we just need a point and a slope. We have a choice of 2 points. It does not matter which point you use, but pick one. I'm always going to choose a point with a 0 in it because zeros are easy. I'm going to write down my formula. Y minus y1 equals m times the quantity x minus x1, and plug in our stuff. So we have y minus y1, happens to be a 0 right there, equals our slope of negative 4/3. And in general, I put the negative with the numerator. It just makes life easier. X minus x1 is my x coordinate here. Don't mix them up. You can't choose a y from one point and an x from a different point. You got to stick with one, all right? Don't mix and match. Doesn't work. Y minus nothing is just y. That makes that easy. But over here, I do need to clean this up a little bit. Negative 4/3 times x is negative 4/3 x. And again, changing 6 into a fraction, negative 4 times negative 6 is positive 24. And 3 times 1 is 3. You'll notice I don't include the negative when I multiply the denominators. I put the negative with the numerators, and then you forget about it. Clean up here. We have negative 4/3 x. 24 divided by 3 is 8. And there's our equation. Left, right, equal sign. Okay. And over here we have order pairs 6, 3 and negative 6, 1. And once again, we're missing the slope, so we need to figure that out first. Y2 minus y1, so 1 minus 3 over x2 minus x1, negative 6 minus 6. 1 minus 3 is negative 2. Negative 6 and a negative 6 is a whole lot of negatives, 12 of them. And that is going to turn positive for us. And they reduce by 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. So we get a slope of positive 1/6. And once again, I need to pick one of these points to use. I'm, again, just going to use the first one. I don't like negatives, so I'm just going to choose the positive ones. Again, it does not matter. So, y minus y1 equals m times the quantity x minus x1. And let's plug our stuff in here. So we have y minus, in this case, 3, equals our slope, which is positive 1/6, times x minus our x coordinate, which is a 6. All right, we have y minus 3 equals, I'm going to do a little distributing. 1/6 times x is 1/6x. And then 1/6 times -6. Well, 1 times -6 is -6, and 6 times 1 is 6. And of course, that reduces to a 1. So you get 1/6x minus 1. And again, I'm just going to add the 3 to get y by itself. So we get y equals 1/6x -1 plus 3 is a positive 2. If you need to use your calculator, it's totally fine. Hopefully by the end of this year, your skills will be stellar. All right, last two here. And again, these are special cases, and a quick picture can really save a lot of work here. We have these ordered pairs 4, 8 and 4, 3. And maybe right off the bat, you notice something, but I'm going to go ahead and just make a little sketch here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. All right, 4, 8. There's the point 4, 8. And 4, 1, 2, 3, right there. All right, well, those are stacked vertically. What kind of line is it? A vertical line. And of course, when you happen to look at these ordered pairs that are nicely written out and stacked up all nice and neat, what do you notice? That the x is 4. Always. Do we care about the y values? No. The x is 4. And maybe you notice that right off the bat. The equation of a vertical line is always x equals some number. Very easy. Let's look at D. 2, 5 and -3, 5. Maybe you noticed something there. But once again, I'm going to take a little bit of time just to really drive this home. If we were to make a little sketch, 1, 2, 1, 2, 3, 4, 5. There's the point 2, 5. And 1, 2, 3. -3, 5 is right there. And we have what kind of line? A horizontal line. So the slope of 0. Well, when you look at those ordered pairs, what do you notice? We notice that the y is 5. And maybe you notice that here. Well, the y is always 5 is the equation of any horizontal line. Well, not any horizontal line, but you just choose the y values. And that's going to give you the equation of a horizontal line. All right, ladies and gentlemen, that's it for me. You have a Delta Math assignment to work on. Thank you so much.